final 4 questions on this worksheet. So you'll be all solid on this. Okay, so now we have the worksheet says, suppose that instead of the level section and the springs, they're talking about instead of having this up here, what if we had this? So look, I'm just going to stick this in here. We're going to grab this, go like this. We'll just put that right in the diagram. Let's see if we can do it. Not bad. Look at that. You get the idea. Bam. And then we'll just kind of erase this. Okay. Like that. Erase that. Okay, so now the track goes like this. It goes up like that. So what is the maximum height above the reference level that the van reaches? So earlier in the problem, they told us the reference level was down here. This is what they defined as the reference level. So the van is going to go up like this. Now look, what happens for a split second up here? Velocity goes to 0, right? For a split second, the van stops. Now, who remembers the total mechanical energy at every point in this worksheet? 1 joule, right? Because it says there's no friction. There's no friction in this problem unless otherwise specified. Like previous in the worksheet, they told us that there was friction from D to E, but now we're back to a different situation. No friction. All right, so look, what type of mechanical energy does the van have up here? It's potential of gravity. And why no kinetic? Because it stops. So basically, the way you solve number 9, is you go, the mechanical energy up here is going to be in the form of potential of gravity, which we know is equal to 1 joule, right? Okay, what's the equation for potential of gravity? mgh. So basically, all the energy is in the form of potential. You know, one of the ideas here is energy just changes from one form to another. It goes from kinetic to potential, back to kinetic again, sometimes kinetic and potential. But when the van is at the highest point, all the energy is in the form of potential. So set that equal to the 1 joule, and now you can solve for H. So H is going to be mg. I'm sorry, not mg. It's going to be 1 over mg. 1 joule over mg. So that's going to be 1 over the mass of the van is 0.1, right, over here. Mass of van is 0.1. And then gravity is 10. So this gives us H equal to 1 meter, which is the answer right there. Okay, number 10. Suppose that someone reaches in. So you know what? I want to revert this. Clean this up again. I'll grab. Here, I'm just going to save this. So we're going to grab this, stick it there. Okay, so somebody reaches in and gives the van a push. Look it. If somebody reaches in and gives this toy van a push, so like when the van is right here, look, is that a force? If somebody pushes the van, is that a force other than gravity or spring? Yeah, dudes. Yes. Put your cell phone away. This is quality stuff, man. This is quality stuff. I'll be meeting a student in about 2 hours who's going to be paying big money to go over this. Not any of you. She goes to an inferior school, which I shall not name. Okay, but everybody's getting. No, not PV. PV is PV and no. My wife teaches at PV. How could it be inferior? Okay. Somebody reaches in and pushes this van, right? Somebody reaches in, pushes the van. Is that a force other than gravity or spring? Yes. So mechanical initial plus or minus the work of somebody pushing is going to equal mechanical energy final, like that. So mechanical initial plus or minus the work done equals mechanical final. If somebody pushes the van, what does it say right here? In the direction of motion, look, if somebody pushes in the direction of motion, is that going to add energy or remove energy? That's going to add energy, so let's just go with plus. Okay, so it's plus work. Now, what's mechanical energy initial? How much energy did this van have? 1, right? 1 joule plus how much work did this push do on the van? It says right here. 0.5 joules, and then that's going to equal mechanical final. So the question is, what is the maximum height the van will reach this time? So again, look, the van goes up here. For a split second, the velocity goes to 0. So what's the energy going to be up there? Potential. This mechanical final here is going to be potential of gravity. So we have 1.5 joules equals, what's the equation for potential of gravity? Not 1/2, that's kinetic. mgh, so H will be 1.5 over mg, so that's 1.5 over 0.1 times 10, which is 1.5. H is 1.5 meters. And then the second part of this question, if the shove is in a direction opposite the motion, so look, the van's going up the hill and somebody pushes it down the hill. Is that going to add energy or remove energy?
Add energy backwards.
Dude. Well, I'm reading right here. It says right here, if the shove, so start right here, if the shove is in a direction opposite the motion, that's gonna remove energy, right? So all we got to do is change this plus, change the plus to a minus, right? Same thing right here. Change the plus to a minus. So now we have 0.5 joules, right? 1 minus 0.5 is 0.5. So this becomes 0.5. That becomes 0.5, and the answer is 0.5. So the answer number 10 is 1.5 and 0.5. All right, number 11. Under the conditions stated in the first part of number 10, let's clean this up. So the conditions for the first part of number 10 was basically what? So our number 11, mechanical energy with the push. What's the mechanical energy with the push? 1.5 joules. When it reaches point B again, so it goes up, and then the van comes back down like this, goes through the loop. Now look, at point B, what type of energy does it have? It's got kinetic energy and potential energy. What are both of those equal to? Now 1.5, right? Instead of 1, it's 1.5 because the push added half a joule, right? We can figure out the potential. How do we figure out what that potential is? Potential is mgh. The mass is 0.1. Gravity is 10. How high is the van up there? 0.5. So what's the potential energy up there? 0.5 joules, right? So look, they're asking for the kinetic. Kinetic plus 0.5 equals 1.5. So what must the kinetic be at point B? 1. Bam, the answer is 1. I have no idea if you understand this.
Yes.
Good. One person does. Two person does. Okay. Two person does. Okay. Number 12. Oh, just enough time. Under the conditions stated in number 10, so basically for number 12, they're telling us mechanical energy is 1.5 joules because we're including that push. What was the elastic potential energy stored in the spring? So the van, look, the van hits the spring goes smush, 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 smush. For a split second, what happens? It stops, right? The van smushes into the spring. For a split second, the van stops. What energy do we have for that split second? Everything is in the form of what? Potential of spring, right? When the van stops for that split second, all the energy is in the form of the spring, so therefore potential energy in the spring is 1.5 joules.